So here I have a set of data and I want to find the mean and median of the data. But what I want to do is actually use this GeoGebra applet to do that. So you'll see that I have them typed in here and then I can click dot plot and it'll create this dot plot for me. And if I hit plot median and plot mean, then it will actually show me the mean and the median, which are 10 in this case. So I'm going to record the mean 10 and the median is 10. And this makes sense because you can tell from the shape of this data that this is symmetric data, so the mean and the median should be about the same. So the next part is going to ask us to go through and actually change some values to see what's happening to that mean and to that median. So the first thing I'm going to do is add two values to the original data set that are greater than 14. So I'm going to go over here to my data set, and next to 14, I'm just going to add maybe 15 and 16, just two that are greater. And so you see what happens in the visual here is the median is actually still at 10. So our median is still at 10, but our mean has now jumped up to what looks like about 10 and a half. If I hit show statistics, it'll be very specific. So I see right here my mean is 10.55 and my median was 10. So now I'm going to look at what happens when I add two values that are less than 6. So instead of 15 and 16, let's go and add maybe 4 and 5. So we see now that the mean has jumped down to 9.45 and the median is still at 10. You can see this in the picture, that when I add some smaller numbers, my mean moves down, my median is still kind of staying in that same position. Okay, well, what if I add one value that's greater than 14, but one that's less than 6? So let's keep the 4 that's less than 6, and then we'll add something greater than 14, so let's add a 15. So I see that my mean and median are actually pretty close this time. So my mean is 9.95, my median is still staying around 10. So they're actually pretty similar when I add a smaller number and a larger number. The last one says, what if you add 50 and 100? So some really drastic outliers to this. So let me add 50, comma, 100, see what happens. So you can see, even if I look in the picture, the mean jumps way up here. So the mean is now at 16.5, but the median is still staying at 10. So you can see in all of these data sets, when I made a couple of changes, the median actually happened to stay the same. Now that's not always going to be true, but in this case, remember, median's the middle number. And if you look at this data set, there's a lot of 10s that fall in the middle. So it makes sense that it would be one of those middle numbers. But the mean, the average, is being affected. So when I'm adding a bigger number, like in A and D, my mean is getting bigger. When I'm adding a smaller number, like in B, my mean was getting smaller. When I add one to the beginning of my set and one to the end, the mean actually kind of stays the same. It's like it balances out. That I want to create a uniform distribution with data between 4 and 12. Well, uniform, I remember that means that like all the data values, like if I draw it out, it's going to look like a rectangle. So there might be 2 here, 2 here, 2 here, 2 here. They all have the same amount. Skewed to the right with the values at most of the values at 10. So my values are going to be pretty much around 10, so maybe 10, maybe 9, but they're going to be skewed to the right. So there's going to be some values to the right or some larger numbers than 10. They're going to be skewing the data. Skewed to the left with most of my values at 10, so I'll have most of my values around 9, 10, 11, but then I'm going to have some lower values, so maybe 3, 4, 5 that are going to pull my mean to the left. And the last one is symmetric with most of the values at 4 and at 16. So I'll have a bunch of values at 4, some in between, and then a bunch of values at 16. So I'll kind of have that bimodal shape to my data. So I have displayed a couple options here for you to look at. Feel free to pause the video and graph any of these if you'd like to see what they look like. But here we have uniform data because I've got 2 4s, 2 5s, 2 6, 7, 8. So it's the same amount of all of them. And this is symmetric, so the mean and the median are the same. The other one that's symmetric is the one that says symmetric with values between 4 and 16. So you see I have 5 4s and I have 5 16s because I want most of my data there, but then I have a little bit of data in between. So a couple 6s, a couple 14s, an 8 and a 12, and then my mean and median are the same. When I have skewed data, that's when my mean and median are not the same. So you see that when I have data that's skewed to the right with most of my data at 10, or left, most of my data being at 10 is going to give me a median of 10, but my mean is changing. So skewed to the right means I have numbers to the right of 10. So you see some of these larger numbers to the right of 10, and that is going to pull my mean up. So you see that it's pulled up a little bit. Skewed to the left with most of my values at 10. So most of my values are over here at 10, but then I added a couple to the end that are actually smaller than 10, which skews it to the left, which means it pulls down my mean, so my mean is smaller than my median.